Data transformations. Overview of the course. We're now diving here into the data transformations and data tables. Previously, we've discussed why we work with data, and a little bit of the ethics, and a little bit of the reasons and the motivation why we work with data. Today we discuss the what and a little bit of the how. I hope that I can go through the what rather quickly and just keep giving you the tricks of how to work with data in this lecture. Yeah, but first I need to introduce you with a new term, the tidy data. Have you heard that before? Is anyone familiar? Mattea? A little bit? It's these three sentences. If these three criteria are happening, then your data set is tidy, like capital T tidy. People just made up that kind of term. So every row is an observation, every column is a variable, every cell is a single value. Here is an example of a data set that is tidy. Let's look at some examples when the data set is not tidy, and can you please tell me why they aren't? Let's start with the first example here. Why is this not tidy? Which rule is broken?
The last one, the third one.
Yeah, so two values here in one cell. Yeah, not epic. Next one, here. Which rule is broken?
It kind of combines multiple observations because it has the urban and the rural.
Exactly. Next one. That one. What's wrong here?
I'm not sure I'm convinced for the second one. I don't get why.
For the second one.
Why can that not be one observation?
You can treat that differently as like two different measures, but then your measures become vaccination urban, vaccination rural. This is instead like the meaning of vaccination is that it's measured like one thing. You know, there is not such thing as rural vaccination and urban vaccination. So this is like some very weird data modeling that people who wanted to remember the world is like so diverse and it's so always changing and it's complex, and then we have to compress it into our data tables. So when someone who made this data table compressed the world into that data table, they've created two separate entities such as vaccination urban, vaccination rural, which do not, they don't exist in a world like that. It's just vaccination. So it would rather be better to have them rural and urban noted like that, and those would be the two separate observations. That's like the explanation of why they are two different observations and we have them in one row. Although it is sometimes you have your data system and you find it convenient to do exactly this, but then you're breaking the rules, and maybe why you're breaking them. So that's on you. Yeah, you may break the rules when you know why you're breaking them and if it's worth it. Okay, the next example, we have indicator vaccination here, and suppose there could be population and income and many other indicators in the same column, and they would have all of them different values there. So which rule would not be met in that example? Yeah, Eden?
Every row is an observation. Vaccination isn't an observation.
It is still an observation, so that rule still complies.
Every cell is a single value because Brazil and urban are in the same.
Yeah, that one is broken, but there's one more broken rule, and there's only one left. So that gives you no options.
Every column is a variable.
Yeah, so then you package multiple variables in the same column. Yeah, so or you make each column, instead of having variables in the columns separately, you all smash them together in the same column there. And then finally, 2015, 2016 here, well, that's just easy. There's, again, multiple observations. in the same row. Yeah? And then the tidy format would be something like this. How many dimensions are here? Is that still confusing? Please deconfuse that part. Watch the previous lecture on visual mappings.
4.
3. Why not 4? Because vaccination is dependent variable, and these are independent variables. So there is like a limited example, and the year here is just that's the same value, and Brazil is just the same value. But imagine you have like multiple countries, and you have multiple of them years, yeah? So it's 3-dimensional. I have a little bit of a different example now, and here, in that one, I'll make it larger. So what are the dimensions here? I think we had that example before. Let's repeat that. What dimensions here? And we just have Afghanistan here. So if we like scroll down, there is Andorra. So there's multiple countries and multiple years.
Is it 4?
Why?
It seems like the population is the dependent.
Population is dependent. What about life expectancy?
Life expectancy might be also dependent.
Yeah.
In
So
that case, it would be 3.
and GDP?
Yeah. So 2.
2.
I don't know. I feel like that's what I was confused about what you just said earlier. Like I feel like you can make an argument for.
I am about to make that argument, but just for the normal case, did you see how this is 2 dimensions?
Yeah.
Yeah. Now I make argument that this table can be 1-dimensional, the exact same table. How can that be possible? I need 1 dimension, so 1 column of values that would uniquely identify my observations. Do you see how that's possible in this table? Yeah, Shalene?
The year increments by 1 in each row.
Yeah, but that's not enough because the same year happens in multiple countries.
The population, because it'd be like pretty unlikely that different countries would have the
I feel like you're cheating a little bit. Yeah, you're cheating a little bit. But you could use like it's convoluted. It's so cursed. Yeah, but you could use population as a key to your data. Yeah, it's not what happens normally though.
Yeah.
Please make one more. It's very creative though. Make one more example or solution. Hint, think outside the box. The box starts here. This is the box.
You can have like.
Honey?
The row in the index.
Yay! Exactly. Hey, whatever software I used to open this, have my row numbers, and those are actually enough to identify the rows which are happening. So everything could be a dependent variable except the row number, and the row number would just show me where to look. Is that useful? No, it's not useful. But sometimes that's the only thing you have. Did you see this penguin dataset in Observable? The penguins don't have identifiers on them. They don't have passport numbers. They don't even have names. So that dataset is 1-dimensional. Because we can use the row numbers to identify the penguins. And we don't have any other way to do that. Why is it not 0-dimensional? Remember when we made a color on the tools page? Remember when we turned that into a constant? Did I break it? I think I did. single color. So that's the color encoding here is 0-dimensional. Why? It's just one number. You can't distinguish one number from the other number, it's only one number. So a 0-dimensional data set is one value. That's why your penguins are not 0-dimensional. Penguins at least have to be 1-dimensional. And for our convenience, we should use as many dimensions as possible in the data, because then we're more flexible with how we work with data. Coming back to this example, then we can, have averages of all the years in the country, or we have like a maximum of all the years in the country, or we can do average of all the countries in certain years, or we can do sum of population for each year. Then we have a world population. Yeah. So having multiple dimensions in the data table is helpful for us, because then we're more flexible to use that data in the software and further. Yeah, so that's the discussion about the dimensions and measures. Again, I'm not sure how to explain that better. I guess the only better explanation that you're gonna get is when you start working with data sets. Is anyone done pizza data set already? Yeah? Alright, cool. So then you kind of start working with data, you start wondering, okay, what are the dimensions in my data set? What can I do with them? What are the keys that uniquely identify my observations? And then you internalize that knowledge, and then it's in your mind through practice, rather than me just downloading theory on you. Yeah. So then it's less theoretical. This is new stuff. I haven't done that before. So when you work with data, I do advise you to set system preferences such that your decimal point is actual point, and I think you're all from the United States, is it? And you have decimal point as an actual point. So you live a very lucky and happy life. The Europeans have decimal commas. And that's so annoying, because you get a data set from a European, and the numbers, they have like commas in them, and you would think it's 1,000 because you're Americans, but it's actual decimals. Yeah? This leads to situations like this I have here. Here is a data set in CSV file, which I had just like this before I opened it in the dataset editor. And I have like 3.8, 1.7, 3.4, 9.2, 14.0, 7.5. But then I opened this in numbers. You heard of numbers? This is like Excel but made by Apple. And then I saved the same file. Just opened and saved the same file. And see, this is what it turned into. Not only did it replace my commas to semicolons, so now it's not comma separated values anymore. Now it's semicolon separated values. But also, look at this. What did it do to my data? It interpreted that as thousands, and now we did this. So the system preferences, it helps you to avoid this kind of situations. And then you also need to actually look how your data is organized, and maybe you need to do some manual changes. What are these manual changes? Let's look at them here in more closely. So first you need to deformat the numbers. And by deformatting the numbers, I mean that you should remove the space, you should remove the dot, and you should remove the comma when these are supposed to mean your digit groupings. Yeah, by 3-digit groupings. And the legal format for computers is something that looks like this, or you can use the scientific format that looks like this. Yeah? So no surprise there. Currency symbol, remove. Whatever separators, remove. here, just keep the decimal point. That's the only thing you keep. Percentages, remove, because this is your presentation layer. So you add them back when you present and you format the numbers on your presentation step. But your dataset should have like 18 or like 0.18 if you do fractions. So either it should be presented by fractions or 18, but then your like metadata should say that, okay, this column isn't percent. That's how you know. You need to add percent later. Yeah, empty values should actually be empty. Yeah, I've downloaded many datasets in my more than a decade of life with data, and people just put like dash there or double dash or dot or 2 dots or 3 dots in their Excel files, whatever. So, and then if you have like a double dash here in one of the columns, that's supposed to mean that this cell is empty, then your whole column turns into a string, because now you have something that is not a number in the column, and your software will be like, okay, these are categories now. I use my population as unique key. Yeah, and then remove any extra headers. I have like a tiny example here. Let's like increase that. Oh, I actually have it in a larger thing here. So here it's like row number 1, highest completed education by cities. Row number 2, permanent resident population age 25. 3 is empty. 4 has that and that. 5 has that and that and that. So no machine kind of reading your dataset will be able to handle that. You're supposed to just have a single row with headers for your columns. And you need to then move all of that to somewhere else in your data model. And I hope we'll have enough time so I can show you how I do that in Gapminder. But also this example is coming data, it's data from Switzerland, and I had once worked with data for a Swiss government, or whatever, they've presented data about their provinces. But look how they do the 3-digit separations. They use apostrophes. Yeah, so every country does it a bit different. United States does that. So comma, comma, and then point for decimal. And then if you're like have bad eyesight, or you're like far away looking at this, you don't even like see the difference between comma and decimal point sometimes. So because they're so similar. So then I advise to present values like that with like a little bit of a space here, and then keep the decimal point for the actual decimal point. But it gets worse. Sweden uses them other way around. And India groups digits by 2, and then there is a group of 3. So it's also inconsistent here, inside that single format. Switzerland uses apostrophes, and I advise to use the space, because that's like, it gives you like a nice little break visually, so you can group the digits visually, and then it doesn't do all of that confusion. However, this has a problem. Do you know what? Do you know what problem does that have? When you do like book publishing, layouting, or like web design, and you're like out of the length of the page, or whatever, your page finished, then that part will jump to the next line. And then that's not nice. Yeah, that's not nice if this stays on one line and the rest jumps onto the other one. So typography and book publishing and web design has something that is called non-breakable space. It looks just the same as your normal space, but it's non-breakable, so the whole thing will jump to the next line if it doesn't have room. All right. And then, like I mentioned, the currency symbol here is a disaster. See, they have like dot dash, so instead use unit measurements somewhere else and deformat these numbers. I think it had something else here. Maybe I move the things around. See, the empty values. Satana. So that's not good. That's not smooth. I'll try to make it smoother. That's also not smooth. But we've done this bit now. Do you have any questions about this bit? No, then we go to the next bit. The next bit is a bit more entertaining. It shows the level of hell where you end up for using different date formats. So if you use the ISO format, you don't end up in hell. That's how you avoid that situation. So what is so good about it? If you use your dates starting with year and months, then day, then you get, oh, here's my window that I lost. You get sorting for free, and I'll show you what I mean. I have my job contracts and everything, and here's my payments from DIS, and see, like if I add like this in the beginning of my documents, and this is not like fully consistent, so I can make it a bit more consistent. But by doing this, if I like have sorting by name, I get sorting by date for free. So this is very useful. In your photo, pictures, whatever, that's also useful there. But Europeans do this thing, which is like, okay, it's understandable, and it's maybe like more human, and then the human readable ones are here, but it doesn't sort nicely, so that's like a no for me. And then there's like some weirdness happening here in the middle zone, and then you have the American format that is pretty deep here. That's the middle endian, so you have, what is it, month, day, and then year. However, that's not the worst. The worst is when Europeans use the American punctuation to show their own order of day, month, and year. So then we end up with like 12th of May, 2023. See how that's like ambiguous and not like you would expect it to read like this. But you're, oh no, it's a European date. No, it's not European date format because you use slashes there. So use the dots to show that this is a European date format. Yeah? And sometimes Americans do it the other way around. It's very rare, but it happens as well. I have an example here. Nintendo of America. The Legend of Zelda, Tears of the Kingdom, launches on Nintendo Switch May 12th, 23. So this is the American, like, nothing weird here. Well, it is weird by itself, but nothing more than that. And then in the trailer, they decided they want to be fancy, and they do, like, dots. And because they do dots, now this looks like a European date format, and now that doesn't work anymore. Okay, so punctuation tells you which format are you using.